Hello everyone. This presentation is about the basics of wireless technologies. Data communication is the exchange of data between two devices via some form of transmission medium. So, when we communicate, we share information. This sharing can be local or remote. Between individuals, local communications usually occur face to face, while remote communication takes place over distance. The term telecommunication means the communication at a distance. The word data refers to information presented in whatever form that is agreed upon by the parties which are creating and using this data. For data communication is to occur, the communication devices must be a part of communication system. So there are five components in the data communication system. The message is the information that to be communicated. The sender is the device that sends the data message. The receiver is the device that receives the message. The transmission medium will be a cable or radio wave. Uh, the message travels from sender to receiver through this transmission medium. A protocol is a set of rules that govern data communication. So, what is a protocol? It is a synonym to a rule. Two entities cannot simply send bit streams to each other and expect to be understood. So, a protocol defines what is communicated, how it is communicated, and when it is communicated. There are three key things in a protocol. The term syntax refers to the structure or format of the data, meaning the order in which they are presented. The word semantics refers to the meaning of each section of bits. Timing should be how this data should be sent and how fast they can be sent. So, the standards are some agreed upon rules. Standards provide guidelines to manufacturers, vendors, government agencies, and other parties to ensure a kind of interconnectivity necessary in today's market and the international communications. There are some standard bodies like ISO, IEEE, ITUT. So, what is a network model? So when we post a letter to a friend, there is a process takes place to do that communication through the postal mail. So sending a letter would be complex if there is no existing process or service available from the post office. In data communication also, there are network models to explain the process of data communication. We'll see ISO OSI 7 layers. The first one, physical layer. The physical layer defines the characteristics of the interface between the devices and the transmission medium. It also defines the type of transmission medium. The physical layer defines the type of encoding. So, how zeros and ones are transmitted. The physical layer defines the duration of a bit. The main responsibility of the physical layer is the movement of every bit from one to another place. Then the data link layer, it divides stream of bits received from the network layer into manageable data units called frames. The physical address is in the data link layer. If frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the sender or the receiver of the frame. Flow control, error control, access control are the responsibilities of the data link layer. The network layer is responsible for source to destination delivery of a packet. Data link layer sees the packet between two systems on the same network. The network layer ensures that each packet gets from its point of source to its destination. The logical addressing is in network layer. The physical address is implemented by the data link layer that handles the addressing problem locally. If a packet passes network boundary or to another network outside the boundary, network layer is responsible for deliver individual packet from the source and destination host. The routing happens in the network layer. When independent networks or links are connected to create internetworks, network layer connecting devices, which are routers or switches that will get packets to their destination. The transport layer is responsible for process-to-process delivery of the entire message. A process is an application program running on the host. So, a source to destination delivery of individual packet happens on network layer, and it does not recognize any relationship between those packets. It treats each one independently as though each piece belongs to a separate message, whether it does. So the transport layer deliver message from one process to another. Session layer provide dialogue control. It establish, maintains and synchronize the interaction among communication systems. It is responsible for dialogue control and synchronization. Presentation layer is responsible for translation, compression and encryption. The application layer enables the user, whether human or software, to access the network, provide user interfaces and support for several services such as emailing, remote file access, transferring, sharing, database management and types of distributed information services. Then there is the TCP/IP protocol suite. However, when we compare to ISO OSI model, it has 4 layers. Physical and data link layer act as one layer, then the network layer, then the transport layer, and the session presentation and application layers are as one layer. There are some addresses associated with this TCP/IP protocol suite: physical address, logical address, port address, and some specific addresses. We'll see what is the relationship between these layers and the addresses. Physical layer has physical addresses which belongs to the underlying networks. Network layer has IP and other protocols, and it has logical address. Physical address will change, but logical address usually remains same in communication process. Transport layer has SCTP, TCP, UDP like port addresses. The application layer has processors specific addresses like FTP, SMTP. Data can be analog or digital. Term analog refers to some continuous data, and digital is for discrete state. Analog take continuous values and digital take discrete values. Signals can be analog or digital. So analog can have infinite number of values in range. Digital can have only limited number of values. So in a sine wave, we can see some attributes like amplitude, frequency, and phase. The maximum displacement of a sound wave is its mean position to its amplitude. We call it amplitude. Frequency is the rate of change with the time, and period is inverse to the frequency. So high frequency means changes occur in short time. Low frequency is changes occur in long time. So we'll see what is phase. It is the position of the waveform relative to time 0. Bandwidth of a composite signal is the difference between highest and lowest frequencies contained in the signal. The Fourier analysis can help to analyze these composite signals. So digital signal is a composite analog signal which is within an infinite or very wide bandwidth. If the available channel is band pass channel, we cannot send a digital signal directly to that channel. We need to convert that digital signal to an analog signal before transmission. So the required bandwidth is proportional to its bit rate. How can we find this bit rate? So if we need to send bits faster, we need more bandwidth. For noiseless channel, the Nyquist bitrate formula defines the theoretical maximum bitrate, or how many signal levels we need. For a noisy channel, we need to use the Shannon capacity to find the maximum bitrate or the upper limit. So there are some impairments of transmission media. So attenuation is the signal getting weaker. So this happens because of the energy loss. When signal travel through medium, it lost energy. Amplifiers are used to avoid this. So the loss or the gain of energy measured by the unit called decibel. Then the distortion signal change its original shape because of this impairment. So, this happens in composite signal. Each frequency component has its own propagation speed when traveling through medium. So different components arrive with different delays at receiver. That means source and receiver has a different signal when compared to the phase. Noise. Noise happens because of some reason. The one is the thermal, the heat. So random noise of electron in wires create extra signals. Impulse, spike. Uh, because of impulse, spikes occur from power lines or lightning. What is the latency of a signal? So latency or delay defines how long it takes for an entire message to completely arrive at the destination from the time the first bit is sent out from the source. We can say the latency is made of 4 components: propagation time, transmission time, queuing time, and processing delay. So propagation time measures the time required for a bit to travel from source to destination. The propagation time is calculated by dividing the distance by the propagation speed. Transmission time the time required for the transmission. So the message depends on the size of the message and the bandwidth of the channel. The queuing time is not a fixed factor. It changes with the load imposed on the network. Then the PCM process. The most common technique to change an analog signal to digital data is, we can say, it is PCM process. So PCM means pulse code modulation. A PCM encoder has 3 main processes: sampling, quantization, and encoding. First, the analog signal is sampled. The sampling process is sometimes referred to as pulse amplitude modulation. We need to remember, however, that the result is still an analog signal with non-integral values. One important consideration is sampling rate or the frequency. Then sample signal is quantized. Result of sampling is series of pulses with amplitude values between maximum and minimum amplitude of the signal. So after its quantization, we approximate the value of the sample amplitude to the quantized value. The quantized values are then encoded as streams of bits. So after this process, to recover the original signal, it required PCM decoder. The decoder first uses circuitry to convert code words into a pulse that hold the amplitude until the next pulse. So in digital to analog conversion, we use modulation. It is a technique used to send information by modifying the characteristics of a basic electromagnetic signal. The basic signal is called the carrier signal. The characteristics of a signal are amplitude, frequency, and phase. Phase shift in keying, the phase of a carrier is varied to represent 2 or more different elements. Both peak amplitude and frequency remain constant as the phase changes. Right? Today, the phase shift key, PSK, is most common than the SK and FSK. However, there is called quadrature amplitude modulation, QAM, that is the combination of ASK and PSK. It is the dominant method of digital to analog modulation, as they say. The simplest PSK is binary PSK, which only have 2 signal elements, one with the phase of 0 and the other with phase 180. So bandwidth utilization is good to achieve some goals while using the available bandwidth. the efficiency can get from multiplexing. It means sharing bandwidth with multiple users. So we have wavelength division multiplexing. It is an analog multiplexing technique for combined optical signals. Time division multiplexing. It is a technique for combine several low rate digital signals, digital channels into one high rate one. OFDM, the orthogonal frequency division multiplexing, that is a form of multi-carrier modulation, which consists of number of closely spaced modulated carriers. Spectrum. In spectrum, we combine signals from different sources to fit into large bandwidth, but our goals are to prevent signal jamming and eavesdropping. To achieve these goals, spectrum techniques add some redundancy. So, a signal that occupies a bandwidth of B is sped out to occupy bandwidth of B's spectrum. All signals are spread to occupy the same bandwidth, BSS. Signals are spread with different codes so that they can be spread at the receivers. Signals can be spread in the frequency domain or in the time domain. Data can be corrupted during its transmission. So, those corrupted data need to be corrected. So, we need to detect those errors and we need to correct those. There can be single bit error or burst. That means 2 or more bits of data can be changed while transmitting. In block coding, we divide our message into blocks. Each of k bits hold data word. We add r redundant bits to each block to make the length n equals k plus r. The resulting n bit blocks are called code words. You will see error detecting from the block coding. So, enough redundancy is added to detect an error in this mechanism. The receiver knows an error occurred but does not know which is in which. Normally the receiver knows an error occurred but does not know which bit it is in the error. So this concept is designed but can only detect the type of errors for which it is designed. Other types of errors can't be catched. So the receiver can detect a change in the original code word when following conditions are met. The receiver has a list of valid code words. We can see in the slide. The original code word has changed to an invalid one. So if it is changed, you can say that there is error. Assume sender encode the data word 01 as 011 and send it to the receiver. So we will consider these cases and we can say that there is an error or not. An error detecting code can detect only types of errors which it is designed. That is the thing in this error detection. It's a drawback. The receiver receives 01. It is a valid code word. The receiver extracts the data word 01 from it. So it is correct. The code word is corrupted during transmission. And 111 is received. This is not a valid code word and it is discarded. The code word is corrupted during transmission and it gets 000 at the receiver. This is a valid code word. The receiver incorrectly extracts the data word 00. 2 corrupted bits have made the error undetectable. So, error correction is the receiver need to find the original code word which has sent. We can say that we need more redundant bits for error correction than the error detection, because error correction is much more difficult than error detection. In error detection, the receiver need to know whether the received code word is invalid or valid. In error correction, the receiver need to find the original code word then. We can say that we need more redundant bit for error correction than error detection. The role of block coding in error correction, we can see the idea is the same as error detection, but the checker function are more complex as the figure. Then the Hamming distance. The Hamming distance between two words is the number of differences between corresponding bits. The minimum Hamming distance is the smallest Hamming distance between all possible pairs in a set of words. To guarantee the detection of up to S errors in all cases, the minimum Hamming distance in a code block must be D minimum equals S plus 1. To guarantee correction of up to T errors in all cases, the minimum Hamming distance in a block code must be D minimum equals 2T plus 1. So almost all block codes today are linear block codes. These are some special block codes like cyclic code and checksum. Cyclic code are special linear block codes with one extra property. If a code word is cyclic shifted, the result is another code word. The checksum is based on the concept of redundancy. Traditionally, the internet has been using 16-bit checksum. So what is transmit buffer and receive buffer? Because of the error control, this problem has been raised. That is, the frames are temporarily stored at the receive end. Check then if errors are detected, request of the frame from the transmit end. The transmit end also keep the frames in a temporary store until the confirmation of the receive end is received. The temporary store is called the buffer and it has a limited memory space. The flow control coordinates the amount of data that can be sent before receiving an acknowledgement and is one of the most important duties of the data link layer. In most protocols, flow control is a set of procedures that tells the sender how much data it can transmit before it must wait for an acknowledgement of the receiver. Incoming data must be checked and processed before they can be used. The rate of such processing is often slower than the rate of transmission. For this reason, each receiving device has a block of memory called buffer reserved for storing incoming data until they are processed. Controlling this process is called flow control. What is the HDLC protocol? High-level data link control is a bit-oriented protocol for communication over point-to-point and multi-point links. There are two types in normal response mode. The station configuration is unbalanced. We have only one primary station and multiple secondary stations. A primary station can send commands. A secondary station can only respond. In a synchronous balanced mode, the configuration is balanced. The link is point-to-point and each station can function as primary and also a secondary one. Carrier sends multiple accesses with collision detection and collision avoidance. The basic idea between CSMACD is that a station needs to be able to receive while transmitting to detect a collision. When there is no collision, the station receives one signal, its own signal. When there is a collision, the station receives two signals, its own signal and the signal transmitted by the second station. To distinguish between these two cases, the received signals in these two cases must be significantly different. In bus network or a REM network, if two computers release a signal to a cable, a transmission medium, there will be a collision of signals. To avoid this collision, the access to the media must be controlled. The media access control is the method called MAC protocol. The widely used two MAC protocols are CSMACD and the token. The function of LLC, logical link control. It handles framing, flow control and error control. In IEEE Project 802, flow control, error control, and the part of framing duties are collected into one sublayer called the logical link control. It is it is in the data link layer. So the frame format of this LLC layer is defined by the protocol data unit. The IEEE 802.3 mainframe structure has these subsections. Remember, so it is the first field of the frame, contains 7 bytes of alternating zeros and ones. The alert or the receiving system to the coming frames and enable it to synchronize its input timing. Then start frame delimiter, SFD, destination address, source address, length and type, data and padding, CRC. So the original attempt used this field as a type field to define the upper layer protocol using the mainframe. So the data field carries data encapsulated from upper layer protocols. So these are the fields in the mainframe structure. Then we will see IEEE 802.11 architecture. Standard defines two kind of services, BSS and ESS. So the BSS, basic service set, as the building block of a wireless LAN. A basic service set is made of stationary or mobile wireless stations and an optional center-based station known as the access point. An extended service set, ESS, is made up of two or more BSSs with APs. In this case, the BSSs are connected through a distribution system, which is usually a wired LAN. The distribution system connects the access points in the BSS. IEEE 802.11 does not restrict the distribution system. It can be any IEEE LAN such as an Ethernet. Note that the extended services set use two types of stations, the mobile and stationary. So, thanks for listening.